again. Right, so that should be done. Okay, I hope you managed to get a bit of a break. So let's get started this afternoon. We were just right at the end of the lesson on job submission. So the one last topic in here is talks about interactive jobs. So interactive jobs are where you actually get a. Can I just check? Is everybody hear me? Okay. Is the quality okay after the problem we had this morning?
You sound fine.
Oh, thanks, William. So interactive jobs can be useful, particularly when you want to test out things very quickly and you want access to a terminal to test the commands you might run and things like that on a compute node, or when you're debugging an application or those sort of things. So what I'm going to show you how to do is how to launch an interactive job that gives you a shell access on a compute node, and then how you can run calculations there once you've got that shell. So let's have so the example actually in the course material shows you essentially how to run an application interactively. So let's so I'm just going to reload this page. So what I'm not going to do the module load xt high stuff because we know that doesn't work. I have spoken to some people here and hopefully that is going to be fixed soon, but it isn't quite fixed yet, I don't think. So what I am going to do is I'm going to use this one and export OMP num-threads. One of the differences between an interactive job and a batch job is that in an interactive job all of the environment settings from your current shell on the system are passed through to the job, whereas in a batch job, usually almost all the environment settings aren't passed through to the job that runs. So settings you make here do have an impact on interactive jobs, but wouldn't have an impact on sort of normal batch submission jobs submitted via SBatch. Okay, so this exports OMP num-threads will persist into an interactive job, but if I launched a batch job using SBatch from here, then that wouldn't persist into the job. So I'd need to set it again in my job script for when the job actually ran. So the problem we've got is that the xt high executable isn't available in the usual way. So I'm going to copy all of this stuff apart from the executable name. Right. And what I'm going to do is I'm going to print my previous submission script to the screen, which does have the right path to the executable. Okay, so that's most of the thing, and then the executable name's the thing from my batch submission script this time. So let's try that. So it tells us the job's queued, waiting for resources. It's been allocated resources, and then hopefully it should just run and pass the output back to us straight away without us having to look in an output file to get this output. Now you may notice, first thing, that some of the output is a little bit different here than what we had previously. So the first two bits are the same. There's 128 MPI processes per node. We're using 2 nodes. There's no threading and that sort of thing. But if you look here, the affinity is now processes it. The affinity for the first process is on processor 0 or core 0 and core 128, which is core 0 and its logical core. So that's the physical core and the logical core. And the next process 1, has an affinity for core 4 and its logical counterpart. And the reason this has happened is because we don't have the placement options in this S1 command. So we wanted to get exactly what we had before. We need to add the hint no multi-thread to get rid of the logical cores, and the distribution block to get the sequential placements rather than this block cyclic placement, which is the default in Slurm, which isn't ideal for placement for most applications. Let's try that again with those options added. Hopefully, it gives us the output that matches. So now you can see the output matches what we got from our non-interactive, our batch job, because we had to add these extra options to S1. Now, if you actually want a shell on the compute node rather than just running the executable interactively, which is what we've done there, I am going to, rather than try and remember it off the top of my head, I'm going to go and look in the documentation, because this will remind me how to do it. So these are all the different options, and then there's an interactive jobs down here. And you can see what you actually do is you give it this --pty option, and then you tell it to run bash to give you a shell. The executable becomes bash. Excuse me. And you can see my prompt has changed to show I'm actually on the compute node now. And hopefully, I haven't done this in a while, so this may or may not work as I expect. You'll see it does. Just take it a while. I wonder if it's over allocated. Here's my problem here. No, it's because I need this. So even the notes is even at the bottom of my screen. So I need to add the usual stuff, but I need overlap. I can't spell because that's over subscribe. And then all the usual cores options. This stuff here, nodes, CPUs for tasks, that stuff. And hopefully that will make it work. I'll just give it a moment. Yeah, okay. So this time it works. And again, because we haven't done the no multi-thread and distribution block options, we get this default round robin placement and including logical cores, which we could get rid of by having those options as well. But you can see this is giving me back my prompt, but I'm still on the compute node, the first compute node out of my jobs, and I can see my job here. It's called bash, and it's running. It's on these two nodes, and how long it's been running for, and all that sort of stuff. So I can play it out on the compute node as if I was on the compute node. What you'll see is if I try to go home, remember the home file system is not mounted on the compute node, so it can't go there because that file system doesn't exist. Okay, and to get back to the login node, I type exit. It tells me it's stopping the job and drops me back on a login node instead of a compute node. Okay, so you can directly access the compute nodes in that way, or by using bash, or you can run application executables interactively using srun directly from a compute node without the need to write a job submission script and all that sort of stuff. There is a bit more fiddling once you've got an interactive bash shell on a compute node about using srun again, because you need to give these extra overlap and oversubscribe options to tell it that I know you're already running srun, but I want you to launch srun again and reuse the cores for this executable. Okay, so that was the longest session, we've had so far, which spanned over the lunch break, covering submitting jobs, both batch jobs and then interactive jobs, and also the different sorts of placement options for processes and threads that you have on ARCHER2. As I've said, there's a lot of information here in the running jobs section of the ARCHER2 user guide, which covers more complicated usage things. So things like job arrays, where you have multiple sets of jobs all launched at once, dependencies between jobs if you want to create a chain, multiple S run commands in the job script. Say you want to select 100 nodes, but then run something different on each of the 100 nodes. More about process placement, interactive jobs and heterogeneous jobs where you have multiple executables linked together and sharing MPI communicators and things like that. Privacy access, reservations, and serial jobs, which we haven't really talked about before, and some other topics, more advanced topics like that. So there's a lot of stuff here, and so this is just to get you introduced to the most basic bits of Slurm and the schedule on ARCHER2. I am going to move on to the next section. Please stop me or ask questions if there's something here you want to that's not clear. So this short section is about being a good ARCHER2 citizen. Right at the start, I said we include this because ARCHER2 is a shared system, and while we've set up the system and tried to manage the system in such a way so that users can't affect each other, there are places where you can, because there's still shared resources. And the main places where there are shared resources where you can affect other users are the login nodes, which are shared by all users, and file system access, which is shared by users as well. We'll talk quite a lot about login nodes here. I won't say much about the file system. Generally, what you'll end up seeing if the file system is contentious, you'll see slow access to files and things like that. You'd see this typically on the work file system, and it's usually because another user is doing some sort of non-optimal data access on the system, or you're doing some sort of non-optimal data access on the system. Again, that's a more advanced topic. If you see that sort of problem or want help with that, then you can contact the service desk, and we can look at people's applications, look at the I/O pattern, and recommend how to improve things going forward. But in this section, we're going to cover being a responsible user and protecting your data. And hopefully at the end, you'll be a more considerate person, more considerate user, and you'll understand a bit more how to protect your critical data. So what can you do on the login nodes and what shouldn't you do? So what the login node does a lot is it manages users logging in, creating, editing files, compiling software. And they're generally, although they're very powerful systems in their own right, they're not really designed to run heavy computational work. That's what the compute nodes for. And you'll get poor performance, and you may affect the experience of other users using the same login node. So you don't really want to run anything compute intensive or IO intensive or anything like that on the login node. Quick testing can often be fine, usually something that runs for less than 5 minutes. If you're using too much resource, then other users may see things like login sessions start to hang, freeze, and slow down and things like that. So you can always use the command psux to list the processes you're running on login node, the amount of CPU and memory using, and the kill command can be used along with the PID to terminate any process. So if I run it here on mine, what am I running on the login node? I'm not running very much at all. Okay, these are all just standard login processes, and they've got bash and then the command I just ran. Okay, and you can see none of them are CPU intensive or memory intensive. If I wanted to kill one of them, I could use this PID along with the kill command to do it. So there's a list of some random commands here which would probably be okay to run on the login node. Well, obviously everything's subjective, and you can't tell everything from a command name exactly what it's doing. But looking at this list of things, I would think that make is okay, right? That's used as part of compilation and is what people do day to day. Create directories.sh is probably going to be okay as well. You know, it's the usual sort of data organization. Of course, you can overload file systems if create directories is trying to create 1 million directories or something mad like that. We'll talk a bit more about that later on, that sort of problem. But from its name, it looks like it's going to be okay. And tarring up a file is pretty standard data workflow stuff, so that's fine. These other two things, physicssim.py, sounds like it might be computationally heavy, and running molecular dynamics sounds like it might be computationally heavy. So they both sound things that may be more well suited to running on the compute nodes rather than login nodes. Everything's relative, everything depends on size, and everything depends on users understanding a bit about what they're doing and being considerate in what they do with people. If you do experience performance issues with login nodes, slow response and things like that, please report it to the service desk. We can investigate, and it might reveal that people are doing things they shouldn't do, or it might be that just that something you're doing that's non-optimal, that we can advise you on how to improve things. It says you should use the login nodes to log into other external services. Generally, although this can work, we don't automatically kill such processes. If they get heavy, ARCHER2 is not really a jump host to other places. So outgoing SSH connections, it says will be killed. I think can be killed with no notice here. So there's no guarantee that they would work. So it's not a good idea to do that way. More critically, you are part of the terms and conditions of access to ARCHER2 are that it is only you that uses your user account. You're not allowed to say, oh, well, I created one user account and everybody in my lab, I'm just going to set up a shared password or shared SSH key and TOTP and things like that, and everybody can log in and use it. That will just end up with you all getting banned from using ARCHER2 for a wee while things are investigated. If other people need accounts, the process is all automated through Safe. They can just sign up and use their own accounts. So if you share your account name, password, SSH keys, or TOTP credentials with people, will require people to reset their access credentials if it continues happening for maybe more severe repercussions. Accessing another ARCHER2 user account from your account is also not allowed, so SUing or SSHing into another account from your account on ARCHER2, ARCHER2 account from your ARCHER2 account, as this allows you to potentially capture credentials for the other account. Again, if we detect this behavior, we'll have both people involved have to reset their access credentials. It's just easier for everybody else, for everybody, and along with the terms and conditions are more secure if people just stick to using their own accounts and only allow themselves to use their own accounts. I said before about potential problems with create directories.sh if it's doing something very, very high or creating lots of directories. And this is part of this test before scaling up for things that seem sensible on small scale, say creating 10 directories in a little script, could suddenly not work or have bottlenecks that you don't expect at larger scale. Okay, so here I'm going to talk about it in the context of jobs. The same also applies to data management and scripts and things like that on the login node. You should also think about what you're doing and test carefully before you scale up to something that's orders of magnitude larger than what you've done before. So you're charged for your use on ARCHER2, and a very simple mistake in a job script can end up costing a large amount of your budget. So the thought experiment here is imagine a job script mistake that sits doing nothing for 24 hours on 1,000 cores, or one where you've requested 2,000 cores by mistake and only use 100 of them. This problem can be really problematic if you write scripts that automate job submission when running the same calculation or analysis over lots of different input. When this happens, it hurts with you waste a lot of resources, and that's budget you generally can't get back, and other users. So when you're using resources for things that are either idle or not doing useful work, they're blocked from accessing these resources, which are then just being wasted anyway. I guess the other thing I'd say is, and this has certainly hit me in the past, is when the system's busy, it can be really frustrating. You might wait in the queue for hours and then your job fails within the first 10 seconds of starting due to a trivial typo in your job script. This happened to me multiple occasions. This is extremely frustrating. It is very, very frustrating. So what you can do here is you can use the ARCHER2 short QoS to run short correctness tests on your job scripts before submitting the full calculation. And you can also use it to test your automation. You can, if you've got some sort of automation job submission scripts or processes you want to test. You can replace the actual submission commands with something that prints the command it would have run to the screen, and you can just test it on the logger node. Make sure it's printing the correct commands. You could echo the job submission scripts that it's producing and check that for correctness before you use them in anger. I would also, essentially test large job submissions that use large amounts of resources. Before submitting a large amount of jobs, submit one as a test first to make sure everything works as expected. Before submitting a very large or a very long job, submit a short truncated test to ensure the job starts as expected, right? If you queue for 10 hours and then it fails because you've got the wrong path to the input directory, the input files, and that is extremely frustrating. And that could just be tested on the short queue, quite straightforwardly. You've already seen how to access the short QS for testing by using -QS for short. It's been what we've been doing throughout the course so far. And this allows you to use a maximum of 32 nodes for 20 minutes. And that's large enough to test that a job submission script is functioning as expected. It may not be large enough to show that the program is working as expected on your input, but it can at least eliminate the trivial errors before you go any further. Okay. Have a backup plan. So the home file systems are backed up, the work file systems are not. Your data on ARCHER2 is your responsibility, and you need to ensure you have secure copies of data that are critical to your work. You can often use version control systems, such as Git, with something like GitHub and GitLab, that can be used for storing source code. Even if you don't write programs, they're very useful for storing job scripts, analysis scripts, small input files, and things like that, and tracking changes to them over time. For larger amounts of data, you can't use these options, as your storage on these free services is limited. But you could make sure you have a robust system in place for taking copies of critical data off ARCHER2 to backed up storage. To use rsync. I also mentioned rclone earlier that could push things straight to OneDrive or Dropbox, depending on what your university and institution uses. The access to ARCHER2 is almost always time limited. You need to have a plan for transferring your data off the system before your access finishes. The time required to transfer very large amounts of data shouldn't be underestimated, because there's not just the time of transferring the data, there's also time for you to manage the transfer of the data. What if the connection fails halfway through? Do you have to go from the start? Do you have a plan to restart halfway through? How much do you have to babysit and manage the data transfer and things like that? What we typically do is give people 3 months access after their compute time is finished to get their data off and to finish off their analysis and stuff like that. But you should have a plan, ideally before your project even starts, on how you're going to move the data off the system when your project ends, and how you're going to ensure you keep the critical bits of data that you need. Yeah, your data is your responsibility fundamentally. While we do our best to help, and home system, file system does have backups, backups can go wrong. So, you shouldn't be totally trusting of these things. We talked earlier, right at the start, about data transfer. I'm going to repeat some of the tips here. The data transfer speed can be limited by many different factors. It can be limited by the disk speed. The ARCHER2 work file systems are very highly parallel, have a large number of high-performance disk drives. They can support a very high data bandwidth. Even if you have really good network performance, if you're transferring to a single disk or over USB to a USB disk at the other end, then you're not going to see good performance, okay? Because you're limited by the smallest bandwidth bit in it, and the smallest bandwidth there is going to be the USB connection to wherever you're transferring the data to. Metadata performance can limit you. This is the thing we were talking about earlier about if you have lots of files. The metadata performance is this overhead of accessing each file individually before it does the transfer. So combine, as we said earlier, if you've got lots of files, combining them into a single larger file, archive file using zip or tar, can help you with this sort of thing. Data transfer performance can be limited by network speed. More importantly, actually, it's limited by the slowest section of the network between the source and the destination. The network connection between the data center in Edinburgh, where ARCHER2 is, and your university or your institution or your organization might be super fast. But then if you're then going over Wi-Fi to your laptop and transferring data, then you're going to be limited by that Wi-Fi bandwidth, no matter how fast the connection between Archer2 and your institution is. What you can do to solve those sort of problems is transfer to other data centers. Generally, then you have a high bandwidth access at all points in the connection. And you can also be limited by firewalls. Most modern networks are protected by firewalls, and that's certainly true of Archer2 and the data center it lives in. It has very special firewall hardware that's high performance, that does firewalling hardware essentially to try to support very high bandwidth data transfers. But that's not to say at the other end that the firewall is the same. Okay, the filtering of a general purpose network for email, web servers, and desktop machines is quite different from a research network. You may need to find a place in your university that allows high volume data transfers, research data transfers that has special firewall settings to allow high performance. For a lot of people, the volumes they're transferring aren't that high, so most of these considerations don't matter as much. But if you're transferring large amounts of data, you do need to be aware of this sort of stuff. So combining things into a single file is always a good thing to do. But you should, as we said back at the start, think about it before you get to the stage where suddenly you realise I've got 2 or 3 months to get my data off, and actually there's physically just not enough time to transfer the data to where I want to transfer it to within that window. Okay. A bit of planning and thinking about it at the start is really important here. So from the being a good Archer2 system, the key points here I think are being careful how you're using the login node and using it with responsibility. Remembering that your data on the system is your responsibility. Don't run stuff on the login node and don't run stuff on the login node. But think ahead, both in terms of planning your job submission script so you don't waste resources and don't end up with the frustration of things failing quickly after you've waited for a long time. And thinking about your data transfer before you get to the end of the project are key things here. Okay. So there are the major issues, I think, in terms of being a good citizen and ensuring you get the best value out of your use of Archer2. I'm going to skip on to the next section. Please stop me, ask questions if you have anything you want to ask. The other thing I should say is, so I realise often these courses are sort of a dump of information. It can take a little while to process and to understand how it might affect what you're doing in your use. If you do have questions following the course, then please just contact the service desk and say, I was on the course, I listened to this, afterwards I realised this, can you give me some advice and stuff like that? We're more than happy to help with that sort of stuff. So please don't think that once the course is finished you can't ask questions, because just contact the service desk and that's what it's there for, is to answer those questions. So we're actually almost at the end of the material here. I said we would finish early, and I think we're well ahead of schedule, especially with only a few people on the course. It leads to less questions and things move along more quickly. So I've got this section on using SAFE, and then a very short section on where to go for help next. And this section isn't very long either, mostly because you've already used SAFE quite a bit. You used it to apply for accounts, to sort out your credentials, your SSH keys, and your TOTP. So you've seen quite a lot of SAFE already, and we've already shown you also how to gain access to licensed software. So SAFE is a web-based tool developed at APCC. It allows you to manage your Archer2 account, record research outputs linked to your use of Archer2, and then they end up automatically going on the Archer2 website, on the publications page. This is automatically pulled from the publications that people put on SAFE, this list here. It allows you to look at your historical use of the Archer2 service, and if you're a project leader or manager, it allows you to manage project resources on Archer2. It also allows us as service operators to manage resources, to understand how much disk space there is, how much we can allocate out to new projects, helps us with security. You know, if there's suspicious activity detected, we can use Safe to block people's access and things like that. So it has a lot of uses. It allows us to report on the usage of the service back to the people who pay for it, the research councils and the government, that sort of stuff. So you've already seen Safe a bit because you applied for accounts. There is a separate Safe user guide, but one thing that often confuses people is that there's always at least 2 accounts associated with your use of ARCHER2. The account on Safe, the Safe itself, that's linked to your email address usually, and your ARCHER2 login account, which is called a machine account. You can have multiple. I usually fill with my Safe access. If I go back, you can have lots of login accounts. I have lots of login accounts. Lots of login accounts associated with a single Safe login account. And they don't all have to be on ARCHER2. Safe is used for some other systems, EPCC, so Cirrus is one of the tier 2 services. We have various other bits and pieces as well that we manage, and some things we manage on behalf of other groups and other universities around the country, and they can all be found in Safe. So some users also have access to these EPSRC tier 2 HPC resources, and login accounts of these systems often be linked to the Safe accounts. We're not going to document the full use of Safe here, but a few useful things. So in terms of your Safe account, rather than the machine account, so this isn't your login to ARCHER2, this is the Safe account itself. There's a few things we want to mention. One is that you can link your Safe login to your institutional single sign-on. So instead of having to have a separate, instead of having to remember my Safe username and password, I can link it to my University of Edinburgh account, which I have, which means I can just log in my usual way to the University of Edinburgh, and I can log into Safe that way. So if I look in Safe, there's your details here, and there's a register identities button here. So if you link, I'm not going to do it because my Safe account's already linked. But if you hit this register institutional ID, it'll take you to a page where you can select your institution, and then you'll be taken to the sign-on for that institution, or it may just flow through if you're already signed on when you do it, and then that will always be linked to your Safe account. And then when you come to log into Safe, there's a login with institution credentials button. For my one, you can type in the university or it remembers. So this is my University of Edinburgh login. I also have TOTP set up for my Safe login as well as my machine account. You don't have to do that, but because I have privileged access in Safe, it's more secure for me to do that. So I just need to find that and put that in from my app, and that gets me back into Safe. Okay, it's optional whether you have the TOTP for Safe or not. You can change your email notification preferences. So within Safe on your details, there are somewhere, is it this one? No, it's not those preferences. Oh, it's update email settings. There you go. So you can sign up to the different levels of alerts from Safe there. So there's major announcements. That one, generally you can't unsubscribe from. I think I can because I'm a privileged Safe user. Most people shouldn't be able to unsubscribe for that. It's used for important announcements such as major system upgrades, major issues and things like that. Or, for example, the ARCHER2 service is ending. You need to get your data off before date X. There's a service news. We send out a weekly newsletter with links to training and information on what's going on the service and upcoming events and things like that, and other useful information for users. And there's system status notifications. That's when, if the system falls over or maintenance is upcoming, that's the list we use to notify people the system's down, or when it comes back, or those sort of things. Some people like to have that information. Other people don't want to be bothered about it. They like to go and look on the website, because oops, if I go back here, if you look at the ARCHER2 website, there is a service status up here, which has both information on what the current load of the system is, but also service alerts and upcoming maintenance sessions and things like that. So you don't have to subscribe to the emails to find out these things. They are available on the website too. So that's the sort of things you can do with your Safe account. The ARCHER2 login account You can, as you've seen already, if we look at a particular login account, you can see the resources associated with it. So that's both in terms of disk available, how much compute resource, which is CUs, you've got left to spend on that budget and things like that. It has a summary of those sort of things. Tells you when you last noticed you log in. That's only updated very often, whether you've got the MFA set, whether it's active, whether it was created, and all that sorts of stuff, and your SSH credentials and all those sort of things. It allows you to pick up your initial login password. You only have to do that once. You've already done it. Unless you get another account on the system, you won't need to do that again. You see registering and resetting TOTP. If you ever lose your authenticator app or device, then you can, if you just click the set MFA token again, you get a new one, so you can re-register it straight away. As you've seen, you add SSH keys account. You can have multiple SSH keys accounts associated with one account, say for logging in from different places. And we've also seen the requesting access to licensed software. I showed you that for VASP, and those sort of things. You could also record research outputs. So the way this works is that you give it a DOI. So if I do your details here, and then there's a publications, it'll ask me to select the projects that I'm uploading the publication for. And it's gotten, if I look at that one, it says there's none yet. So I can add a publication, and you just give it the DOI URL, and it goes away and finds the publication. So for example, I know there's some DOIs here on the research technical reports bit. So you get an example, here's a DOI here. Hopefully, if I put that in and click add, it's automatically found this publication. So you don't need to fill in all the details. Okay, I'll delete that rather than that again. Okay, so you can do that to record it, and then you can export a list yourself as well. So it can be useful for you for research fish submissions and all that sort of thing you have to do for research grants. You can keep a list in the database here. All that gets published to the ARCHER2 website and used to support the case for future improved compute resources. And also you can export the list for use elsewhere if you want to. Finally, safe. All of the jobs you run on ARCHER2 eventually get pushed up to the safe. It doesn't happen in real time, so when a job finishes, it doesn't automatically go to safe. There's an upload process that happens 2 or 3 times a day. And then once you've got that, then you can report on your usage of safe. So if I go to the service information menu, there's a reports section. Let me just double check something. Yeah, that's fine. So I can look at a user job report, for example, which would list, or a user usage report maybe is a better one. So if I look at my main account on ARCHER2, which will have actually run jobs, there we go. So this is my main account on ARCHER2, and this is for November this year. It's from the 1st of November for one block of 1 month. Where I click preview, what it'll do is it'll plot a graph of my usage over time, over the whole month, and it'll tell me how much I've been charged, how much I got raw use. This might be because I've run some in low priority, which are free. It'll give me a breakdown of my usage by job size. So this is the number of cores used, number of jobs run in that category, the charged usage, that sort of stuff. Okay, and there's various other reports available. You can also, I think all users can run the monthly report as well, which shows the general usage of ARCHER2 over time, things like that. So safe, as well as letting you manage your accounts, also lets you see historically what you've used on the system and how you used it over time. Allows you to upload publications, manage access credentials, and all those sort of things as well. There's a lot you can do there. Okay, so if nobody has any questions on safe, I am up to the final bit, which is very, very short. It's just next steps and where to go for beyond this course. Okay, because this has just been a very basic, quick introduction to Archer 2 in general. The main thing I'd say is the easiest way to get in touch with the service to ask any questions is contact the service desk, support at ARCHER2 AC UK. We have a lot of staff, a lot of experts in different things that you can reach out to through the service desk. If there's a particular issue you want to discuss in more depth, we're happy to discuss via email, via the service desk in the usual way. But we can also arrange online callback sessions, either Zoom or Teams or something like that, at a time of your convenience. So if you want to book a callback with a particular, with somebody who knows something about something, just say what you want to talk about and preferred times, and we can get that sorted out so that you can talk to people. This can often be very useful if you're really struggling with something. It can often be useful for you to screen share with us, see what you're doing, and we can offer advice and help out and demonstrate how to do things and stuff like that. So that works pretty well. But we are genuinely try to be as helpful as possible. So even if you think your question is it's not a great question, or you're a bit worried about asking it, or think it's this question is too stupid, or I'm embarrassed to ask that, but please don't struggle in silence. Go to ask the help desk. That's what they're there for. There aren't any stupid questions. We're just here to help. That's what our job is on the service desk. So please don't feel you can't ask questions. I've referred to the documentation throughout. There is a lot of documentation on Archer 2 covering things from very basic topics, as you've seen in the running jobs. It goes from basic to more complex things. Connecting to Archer 2, for example, has stuff about how to debug SSH connection problems and things like that if you're getting stuck with accessing, but also you can ask the service desk. There's more information on data management transfer. There's more detailed look at the software environment. If you're running your own app, you want to compile your own software and things like that, there's a big chapter on how to use the different compilers and different compiler environments on the system. There's something about optimizing I/O, common I/O patterns, and which ones work best when, and what the right settings are to use on the file systems, things like that. More information on using containers like Singularity, if you're interested in that sort of stuff, and Python, details and data analysis, debugging and profiling, performance tuning, and section on energy use as well. So one of the important things more recently on Archer 2 has been how much energy, how much power it draws, and what the most efficient way of running jobs and things like that is. And you can monitor your energy use on the system. You can control the CPU frequency to try and get the best and the most efficient energy use out of the system as well, and things like that. So there's lots of documentation out there on there which you can look at for help. In terms of training, you found this course. That's great. So there's lots of other courses going on. Some of them are named here, and some of them aren't. But we actually run a lot of different training. I'm going to make this a bit bigger so you can actually read it, hopefully. So if you go and look at the training section on the Archer 2 website, it will tell you what the upcoming training is. So that was the package used one. So I heard noise. Okay. How to benchmark parallel code. So I will answer that in a moment. So let me finish. So these are the upcoming training. Some of it's in person. Some of it will, a lot of it will be online. And he's joined, and there's different levels of courses. You can look at the Archer 2 training courses. There's some sort of training routes thing here with different levels of courses and different things. If you click on these, you can get more information on the individual courses here that are under that list. And finally, if the course you're running, if the course you're interested in isn't scheduled straight away, where you can just ask us, we're happy to take requests for upcoming training. But also, if you've know people at your institution, you've got a group of people who want to take a particular training, then we can come and deliver it at your institution free of charge. And what we typically do is ask the institution to provide a room locally, and we'll send the trainers down. You have a number of people, we'll open up the remaining places more generally, and we can run course. And we've done that quite a lot for people who said, I want this course. And as long as there's a nucleus of people there who all want to go to the course, that works fine. Finally, if the course you want isn't running, or you want to try and work through it on your own, on the past course materials section, there is a list of all the previous courses, and the online ones will all have recordings associated with them. So say you wanted to learn about C++, you can go to the C++ one, and all the sessions are recorded there. And you should be able to access the repository with the materials in for any particular courses. So you can always work through things at your own pace. And as I've said, if you've got questions, you can always email the service. I say, oh, I was working through this course in my own time, and I came across this question or this thing not working. Feel free to ask that sort of stuff. So Robin asked in particular about resources on benchmarking parallel code. So we did have a course on that we've run in the past, and we haven't run it since because there hasn't been a huge amount of demand for it. Just let me see if I can find it. So there was this understanding package performance course last time in 2021, which is all about benchmarking. So you could look at the course materials there, and it goes through understanding your workflow, the connection because it was ARCHER2, we have to make sure everybody's connected. Talk about performance benchmarking, analyze performance, automating collection analysis, instruction to profiling. So that's a sort of intro to that sort of thing. Things have moved on a little bit. We're revamping that course at the moment in collaboration with some people at UCL who've been working with a tool called Reframe, which allows automated testing and benchmarking. Now, they did have some materials somewhere. Let me see if I can find it. I don't know if it was on our, I don't know whether it was here or not. So the answer is no, it's not in this list. So I'd have to find it somewhere else. Anyway, but in short, we're revamping that course and building in the use of Reframe. So I'll put that in Reframe in the chat. There we go. I will put this in the chat so it's there for people. So the idea is it'll be similar to the course I just showed you, the Understanding Package Performance course, with the bits about understanding your workflow and benchmarking concepts. But the actual running of benchmarks, rather than using the sort of bespoke scripting that course uses, it will go into using Reframe, which is a standard tool for these sorts of things, for doing that instead. So you could almost reconstruct that course yourself if you went through the material there, but instead of the automating stuff, you looked at Reframe and worked out how to use Reframe instead. That'd be close to what the course we've got planned for that, to run sometime next year. It doesn't really cover energy use specifically, but that's just the case of having a different optimization metric, right? Instead of top performance, you'd want energy efficiency. So it should be pretty straightforward to replace performance or runtime as your benchmark with energy consumption, and then the benchmark just works the same. So yeah, lots of things. There are various things there, and as I said, if you can't see the thing you want, and you think you've got a group of people who'd be interested in it, then we're happy to try and facilitate that for people. Fine. Is this finally? Not quite finally. Next to finally. You've been on the course, you may or may not have access to ARCHER2 through a project or something like that. How would you actually get access once you wanted to use ARCHER2 for your research? So there are various different routes. You can go through the scientific consortia. If your research falls within their remits, they've got a large blocks of time that they can allocate out. on the system. You just need to go to their website and speak to them and ask about how you join the consortium and get access. It's different for each consortium. They cover a wide range of different scientific research areas from, let's open that up, from like CFD, turbulence, and materials chemistry, and that's materials science as well, the Carl Parinello one, biomolecular simulation, plasma, mesoscale engineering, which is essentially multimodal, multi-scale modeling. And there's also one around X-ray spectroscopy and wave structure interaction for the EPSRC ones. And for the NERC people, there's oceanography and shelf seas, the atmospheric and polar sciences, and the mineral geophysics people. And it has the consortium leaders, you know who to contact. Some of them have links to websites if they have a website for their consortium that you can go to. There's pump priming, which is a small amount of time to test ARCHER2, proof of concept, obtain scaling information for full applications that you can apply for. You can apply for resources via research grants, so you can just write ARCHER2 and start a research application. There are these UPRI access to HPC calls, ones just finished, and they're ways of getting computer time only for a year. They don't provide staff effort or anything like that, but if you just need computer time, you can go this way. They tend to have a call once every 3 to 4 months. So the next one will be due spring next year sometime. There is, all of these are on the access page on the website. It lists the different routes here, times for different applications. There is also the driving test. And having done this course, you could easily pass the driving test thing. So if you go to the test page, you answer a multiple choice quiz about using ARCHER2. It includes things like, you know, how do you submit a job, what file systems are there, all the sort of stuff that's in this course. And then if you complete that and pass it, and you're from a UK research institution, you'll get an invite to apply for an account, a driving test account, which will give you 800 CUs for you to use for whatever you want. The pump priming is a bit more. It gives you 4,000 CUs for 6 months. So it gives you probably it gives you 5 times the amount if you go through via the pump priming route, and then larger amounts via the other calls. That way. If you're not sure how to apply for ARCHER2 or what's most suitable, again, contact the service desk. We're happy to help and advise people on what the best route to go for is. We can point to more specific things about the consortium, about NERC access and non-EPSRC or NERC access and things like this as well. We can talk to you about that and help you out. And finally, in this section, if you have a piece of software and you want to add some functionality to it, or you want to improve its scaling, or you just want to improve it generally, ARCHER2 has these things called ECSE calls associated with it that provide funding for yourself or a research software engineer of choice, or somebody just randomly from within the ARCHER2 team. We can provide experts who don't know someone to add and improve software. It provides staff effort to do software development targeting ARCHER2, and in upcoming calls also targeting GPU architectures. ARCHER2 is mostly a CPU in the system. It's supposed to get a small number of GPUs next year, early next year, for people to try out. So that's the sort of formal end of the material. I am happy to stick around for a bit if you've got any more questions. I am also happy for you to just head off and do something with the time you've got back. Here, I will not be offended if people just want to disappear and get away. That's no problem whatsoever. You will get a request for feedback. Please do fill it in, both positive and negative. I know there were some problems with the audio video at the start, and there was some typos in the material. I've been taking notes of them all the way through, and I will update and fix those, or I'll pass them on to be updated and fixed ahead of the next run of this course. Also, thank you to William and Nathan, who've been helping out today, and thank you, Nathan, for spotting out how to fix that module restore, save module restore thing. We'll add that to the documentation. I think that's not in the documentation at the moment, so that's a useful thing to put in there that we can point people at. That's come out of today. There is another section here. If you're searching for something to do and you want to go a bit further, you could use your accounts on Archer 2 for this course will exist probably for another 3 or 4 weeks. There's a small amount of resource there. You can still log in and keep testing and try things out using the software on Archer 2 and things like that. You can try out. You can use these accounts to try that out. There's not enough resource in there to do any sort of real research, but you can certainly enough resource to play about with things and try things out on Archer 2. And if you have questions, contact the service desk. Obviously, they should be able to help. If you say you're on this course, and that helps too. If you really want to have a go, have an initial go at profiling, there's a GrowMax example here, where you can download an input file, write a job submission script for GrowMax based on the documentation in the ARCHER2 things, vary the number of nodes, see what performance looks like in 90 seconds per day, or you can even look at energy consumption and see how that varies over time if you wanted. Right, so yes, so 2 jobs can share nodes. So Robin's asked for 264 CPU jobs on 1 node. You can do that. It's a little bit fiddly. So in the running jobs section in the ARCHER2 docs, if you scroll down through the table of contents here, there is a specific thing that says using multiple S1 commands in a single job script. So there's running multiple full node subjobs with a large job. That's where every job is 1 node or more. But there's multiple subjobs that use a fraction of a node. Right, so there's 178 serial tasks or 8 subjobs on 1 node each with 8 MPI processors and 2 NPM free processors. And it shows you how to do that, how to loop over and launch jobs that are smaller than a node and make sure you launch them so that they all use different sets of cores on the nodes so they don't overlap. Okay, so that is documented there. So yes, you can. It just gets it's just a little bit fiddly. The thing you can't do is you can't submit a job that says, give me 64 cores, which is half a node, and here's my other job, separate job that uses the other 64 cores on one node. They have to be a single job that, say you were once you used 2 64 core jobs, you'd have to submit 1 job script that ran the 2, and you can't have them as separate job scripts. So that's me finished the material. Like I say, I'm happy to stay here and ask questions, but if you want to head off, that's also fine. Thank you for your attention today. I know we haven't had many people here, but your questions and interactivity has definitely made this easier. It can sometimes be very difficult when there's low numbers of people and nobody responds to know whether there's anybody still out there. So thank you very much for that.